Welcome to question 2 of the 2021 Mathematical Methods Exam 1 for the Northern Hemisphere. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. For question 2, we let h be the function with a domain of all real positive numbers and a rule h of x equals x cubed log e of 2x. For part A, we want to show that the derivative of h is equal to 3x squared log e of 2x plus x squared. So if we want to differentiate x cubed log e of 2x, we can first of all recognize that it's two functions being multiplied together. So we're going to use the product rule. So to help apply the product rule, I'm going to let u be the first function that's multiplied. In this case, that would be x cubed. And v is going to be the second function that's multiplied, which is log e of 2x. Next, we need to calculate du dx. And that's going to be 3x squared. And we also need to calculate dv dx, which is one that you need to take a little bit more care with. So log e of 2x, we could actually use a chain rule to differentiate that, and you'd find that that equals 2 on 2x, which actually just simplifies to 1 on x. So it's one that's a little bit counterintuitive and something that a lot of students make mistakes with, that log e of 2x actually just derives to 1 on x. Next, you could look at your formula sheet and see that the product rule, d dx of a function u times v, is actually just equal to u times dv dx plus v times du dx. So in other words, to apply the product rule, we actually just multiply these two things together and these two things together and add them, so that you form a little multiplication sign the way I've set it up above. So therefore, h dashed of x, the derivative we were asked to calculate, is going to equal u times dv dx. So that's going to be x cubed times 1 over x plus, and then we have v, which is log e of 2x times du dx, which is 3x squared. Then we can just neaten that up a little bit to finish off this problem, because we know that x cubed times 1 on x would give x cubed divided by x, which is actually just x squared, plus, and then the second product that we have on that line up above, we can actually just write in the order 3x squared log e of 2x, which now resembles what we were asked to show in this question. From the examiner's report, we can see that they got the same answer as us using a same line of working, and they go on to say that it was a show that question. So students really did need to show the necessary steps to get that result, to get the mark for that question. For part B of this question, it says let dy dx equal 3x squared log e of 2x, and it says the graph of y passes through the point 1/2, negative 25 on 24, and our question is to find the rule of y. So if we just have a look at what's presented here, if I just put a box around that because it's quite important, dy dx is equal to 3x squared log e of 2x. So that means if we want to find y, we actually need to integrate dy dx with respect to x, which is the same as calculating the antiderivative of 3x squared log e of 2x. So that means to find y, we're going to need to find the integral of 3x squared log e of 2x dx, which relates back to what we were actually doing in part A of this question. So without it being stated in words on the page, this is an integration by recognition question. So to set up this question, I'm going to start with a statement, and the statement essentially captures what we found in part A, and this is the way I like to write it. So I'm going to write that d dx, the derivative of x cubed log e of 2x, is equal to, and then that was 3x squared log e of 2x plus x squared. And the reason I write it out like this is it's now an equation. So if we do the same thing to both sides, in this case I'm going to integrate the left hand side and integrate the right hand side, we'll still have an equals statement. And again, the reason why we're doing that is we can now see on the right hand side we're starting to create the integral that we wanted up above, which I've got in purple. So in the next line, this might get a little bit cramped, so I do apologize. We just want to simplify this as much as possible. So on the left-hand side, we have an integral and a derivative inside it. So those two operations essentially undo each other. So all we're going to have left on the left-hand side is what's inside. So we're going to have x cubed log e of 2x. And I'm going to put a plus c here because we actually have integrated or anti-differentiated, so we need that constant. And that's going to equal the right-hand side, which we can split up over that plus or addition sign. So the first integral, which I'm going to put in purple because it matches what we want, is going to be 3x squared log e of 2x dx. And then we're also going to have plus the integral of x squared dx, which is actually x cubed on 3. So now our job is just to get that purple integral by itself, because that's what we know y is equal to. So therefore, we know that y is equal to the integral of 3x squared log e of 2x dx. And that is equal to, and all I've done here is I've kind of swapped the sides of the equation. That was equal to the x cubed log e of 2x. And then I'm actually going to subtract away that x cubed on 3 term, and we still have a plus c at the end of that. So we've now found what y is equal to with a c value, a constant in there, that we're going to want to find its value using the point that the graph passes through. So if we substitute that coordinate in, wherever there's a y, I'm going to put negative 25 over 24 is equal to x cubed, which I'm going to have as a half cubed, and that multiplies log e of 2x, but x is a half, so 2 times a half is just 1, minus, and I'm going to actually write this as 1/3 x cubed, which is 1/3 times a half cubed, plus c. So we've now got an equation here that we can solve for c. Now log e of 1, that's actually 0. So therefore, this equation that we're solving is minus 25 on 24 is equal to, and then 1/2 cubed times 0 is just 0. So we end up with minus 1/3 times 1 on 8, which is minus 1 on 24 plus c. So next, if we add 1 on 24 to both sides of that equation, we actually get c is equal to minus 24 on 24, which is just negative 1. So once we know what c is equal to, we can replace c in this line of working, and that will give us our equation for y, which is what the question asked for. So therefore, y is going to equal, and it's going to be x cubed log e of 2x minus x cubed over 3 plus c, which is just minus 1. And that is going to be the answer to part B of this question. From the examiner's report, they don't give us much information, but it just goes through and shows that they got the same result that we did on the previous slide.